This unit is going to cover the different types of chemical reactions as well as how to predict what's going to happen given a set of reactants. All the reactions we've talked about this year fall into one of the 5 categories below. They're either a synthesis reaction, a combustion reaction, a decomposition reaction, a single replacement reaction, or a double replacement reaction. So we're going to learn what each of those are. So there's 5 different possible types of reactions. We'll start with synthesis. A synthesis reaction is a reaction where you have two or more things reacting to become one thing. A generic formula for this would be element A plus element B yields compound AB. Right, so when two elements react, the reaction is always a synthesis reaction. So say you have sodium reacting with chlorine, making sodium chloride, that would be a synthesis reaction. You have two elements reacting to form a compound. Notice here that diatomic chlorine is still counting as a single element. Okay, we're making one thing from two things. You can also have two compounds becoming one compound. That's also possible. Okay, so CaO plus H2O giving you CaOH2. That's possible. You can also have a compound and an element combining to form one larger compound. With this example, 2SO2 plus O2 yielding 2SO3. Okay, but the big thing here about how to recognize if something is a synthesis reaction is you've got multiple things becoming one thing. The second type of reaction is a combustion reaction. It's a reaction in which oxygen combines with a substance and releases energy in the form of heat and light. You are burning things. Generically, what this is going to look like is you have some compound plus oxygen yielding some sort of new compound with the original element A and oxygen. Okay, oftentimes A is carbon, but it can be other things as well. Okay, so generically it kind of looks like that. The big giveaway here is that you have oxygen as a reactant. Okay, that tells you you've got a combustion reaction. Sometimes combustion reactions can also be synthesis reactions. So this is an example of burning, say, charcoal. If you have a charcoal grill at home, if you're burning that, right, carbon, it's just pure carbon, charcoal, plus oxygen. You have to have oxygen to burn stuff. You make carbon dioxide. So you got two things becoming one thing. It's combustion since you have oxygen as reactant. It's also synthesis because you got two things becoming one. However, most combustion reactions are not synthesis reactions. So this is an example of burning methane. Okay, this is natural gas. This is the stuff you use with the Bunsen burners, okay, in lab. CH4 plus 2O2 yielding carbon dioxide and water. Okay, in this instance, right, we've got multiple products, so this can't be a synthesis reaction. We're burning, in this case, this is called a hydrocarbon. It's a compound made out of hydrogen and carbon. All right, we'll write that down here. Hydrocarbon is what that's called. And oftentimes when we're combusting things, it's some type of hydrocarbon. They're very combustible. If you are burning a hydrocarbon, in this case methane, that carbon plus the oxygen is always going to give you carbon dioxide. So when you're burning a hydrocarbon, you always get CO2. And if this particular thing here also has hydrogen in it, which a hydrocarbon does, you will also get water. So another thing that you can kind of look for over on the right side, it's not always the case. Sometimes you can have metals combusting, but oftentimes you're going to see carbon dioxide and water over here if you're combusting things. So that's kind of another giveaway in addition to having oxygen as a reactant. Next type of reaction is called a decomposition reaction. This is a reaction in which a single compound breaks down into two or more elements or new compounds. So a generic formula here would be compound AB breaks apart into A plus B. Okay, it's kind of the opposite of a synthesis reaction. Okay, you've got, instead of multiple things becoming one thing, you've got one thing breaking apart into multiple things. You might think when you hear the word decomposition, you think, biology terms. Decomposition is a slow process. It takes some time often. And in the chemistry definition, that doesn't necessarily hold up. This is not necessarily a slow process. This can be immediate. So in the example down here, oftentimes the initial compound, whatever is on the left side of the arrow, whatever the reactant is, it's usually only slightly stable. Meaning it only needs like some sort of slight disturbance to set it off. In this case, this compound is called sodium azide, NaN3. And this, if you run an electric current in it, just a tiny electric spark, it will break apart. It breaks apart immediately. So again, kind of get out of the mindset of you hear decomposition meaning slow. This happens instantly. it breaks apart into sodium metal and nitrogen gas. And so, like, what's this reaction used for? This was actually for a long time what was in the original airbags. That if you were in an accident, it would send an electrical spark into the airbag. This would break apart immediately, and nitrogen gas would fill up that airbag and cushion you as you would be going towards the steering wheel. So that's what this is. Nowadays, we don't really use this. Sodium azide's a little toxic, and sodium metal is not exactly something you want laying around after an accident. So there are other compounds that we've come up with more recently to fill those airbags. But this was, for a long time, what they used, called sodium azide. Our next type of reaction is called a single replacement reaction. This is a reaction in which the atoms of one element replace the atoms of another element in a compound. So an example here, the generic formula is A plus BX yields AX plus B. And what that looks like in terms of substances, you could have lithium plus water yielding lithium hydroxide plus hydrogen gas. And how you can identify these by looking at them is you're looking for an element plus a compound yielding a different element and a different compound. Okay, so element plus compound yields element plus compound. That's what you're looking for. Okay, there are different types of single replacement reactions, and single replacement reactions do not automatically occur. We'll talk about how you know if they occur here in just a moment. The first type is you could have a metal replacing hydrogen or another metal, and that's what that example was on the previous page. You can have lithium in this case, right, which if we're identifying things, that's the A, okay, and here's your, your BX in water, and the lithium goes into where, oops, let me draw that a little bit better. The lithium is going to go to where the hydrogen is, kick out a hydrogen, and hydrogen becomes the new element, right? It becomes the new A. So, over here on the other side, my A is still here, okay? B is still here, and, well, now I've got my, whoops, sorry, that should be X. Apologies, that should be X, and now this is B. Okay, so it kicks out a single hydrogen each time it does this, all right? This is not necessarily balanced as it's written, okay? Same thing happening here, where the copper, okay, is going to, all right, this is the A element, and this is B, and then nitrate is X. The copper is going to go in and try to replace the silver, and the silver is going to come out and become the element by itself. So you have, here's your B, here's your A, and here's the X. But metals do not automatically replace other metals. So for instance, why do we know that copper replaces silver, which is in the compound, but if I try to reverse that, where I've got silver as the element and copper in the compound, nothing happens. So if I tried to do this one backwards, I get no reaction. That's what this stands for, by the way, and you're going to see that pretty regularly in this unit. That stands for no reaction. Sometimes you'll see me write that as no RXN. RXN is reaction. So how do we know if it's going to happen or not? We have to use something called the activity series, which we'll see on the next slide. Okay, so this chart right here is called the activity series. You don't need to memorize this on any test where you'll need it. You will be given it. But it lists which metals are most active, from lithium down to gold. And so how do we use this? How does this chart work? Well, if this is my generic formula, A plus BX yields AX plus B, okay, and we said this reaction does occur, copper plus AgNO3 giving you copper nitrate plus silver metal. If we go through and label the pieces here and make this A, we call this B, and we call this X. Okay, so now we have AX plus B over on the right side. How we know this works is the following rule. If element A is above B on the chart, then the reaction happens. And obviously the opposite, if B is above A, then nothing occurs. So if we look here, okay, if copper is my A and silver is my B, if I come over here and label those things, here is copper, it's A. Silver was B, we said. Well, is A above B? Yes, copper is above silver, so this reaction will happen. Okay, if you try to go backwards, all right, and have it go the other way, well, then silver would be above copper, and you would get no reaction. So that's how we use this chart here. We can also have nonmetals replacing other nonmetals, and that was what was at the bottom of that chart previously. This involves the halogens, fluorine, chlorine, bromine, and iodine. Okay, but here we have to be careful because your A and B are not metals, they are the nonmetals. Okay, so in this example, you have fluorine plus NaBr. Well, if we look at that, fluorine will be my A. Here, my sodium is X and bromine is B. because nonmetals can only replace other nonmetals. So fluorine could only replace bromine. It could not replace sodium. So you go back to the previous slide and look at that activity series. Okay, you would notice it goes, fluorine, chlorine, bromine, iodine, right? And in that order, fluorine is above bromine. A is above B. So this reaction does happen. If you try to reverse this, say, and make your bromine A and your fluorine B, well, your B would be above A, okay, and nothing would occur. So you can have nonmetals replacing nonmetals. You can have metals replacing metals or hydrogen. That's it. Just have to be careful here if you see a nonmetal starting this one off. You can only replace, say, bromine and not sodium. Our last type of reaction here is called a double replacement reaction. This one, generically, okay, is going to look like the following. AX plus BY yields AY plus BX. Essentially, A and B are going to switch places. A and B are switching spots. You're exchanging ions between two compounds. So how you can identify this one is you have a compound plus a compound yielding a compound plus a compound. These are generally going to be the longest looking type of reactions. Okay, so here's an example of calcium hydroxide plus hydrochloric acid yielding calcium chloride and water. Compound, 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 compound. The calcium and the hydrogen have switched places here. Okay. Another example here, sodium hydroxide plus copper 2 chloride. Sodium and the copper switching places. We end up with sodium chloride and copper 2 hydroxide. Okay, and this should be solid, by the way. Just mismark that one there. That's okay. Oftentimes, these are going to be a part of something called a precipitation reaction, or precipitate, okay? And we'll talk later about how to know the states of matter of these products. Okay, so for instance, this one was a solid, and I knew that based on some rules that we will learn later on. Here, this is just letting you know that any double replacement reaction will make one of three things, either water, a precipitate, or a gas. And here are three examples of that. The first one is going to make water. The second one is going to form a precipitate, which is a solid. Okay, and I need to mark that on here. That's actually this one. It's the same one as the previous slide. It just didn't get marked. That one's a solid. Should be an S. Or a gas. Okay, in this last example here, it's making hydrogen cyanide gas. Okay. So those are the three possible things you can make with a double replacement reaction. We are going to focus in on this second one for now, which are precipitation reactions. This first one is part of a neutralization reaction, which you will see when we talk about acids and bases. This slide is just a nice summary of everything. Okay, so if you're not sure, this might be a good place to look. Go ahead and give these a try, and we'll see how you do.